Okay, so here we're going to do an example of writing a trigonometric expression as an algebraic expression with just x in it in terms of x without any sine or cosine. Now before we do this, it's a good thing to refresh students' memory about inverse functions. That is, f of f inverse of x in general, this is equal to x. Right, so I take a few minutes and I just talk about that and refresh their memory. Why do we do that? Well, because when we go back to this, we know this inverse sine of x over 3, as we've already taught, this inverse trig functions give us our angle, whatever theta, give us our angle theta. So now what we can do here, basic idea of equations is we can do anything to both sides as long as we do it to both sides. And when we do that, we're going to end up with an equality. So let's take the sine of both sides. Since this is an inverse sine, take the sine of both sides. Now, why did we do that? Well, that's because of this. The sine is a function. Sine is a function, so the sine of inverse sine of x over 3 is just x over 3 because of our basic rules of properties of inverse functions. So here we have the sine of theta, as I just explained, this is just x over 3. So now we can construct our triangle from this. And when we draw our triangle, let me call this angle theta. That's our 90 degree. Sine is opposite over hypotenuse. Then we use the Pythagorean theorem. This square plus this square equals this square. So this square minus this square is equal to this. And this is the square root of 9 minus x squared. All right, so now that we have that, well, we go back up to here. The inverse sine of x over 3, we let that equal theta. So this is equivalent to theta. So this expression is the same as cosine theta. Well, what we just did here, we constructed our triangle. Cosine is adjacent over hypotenuse. So this is the square root of 9 minus x squared over 3. So now we have the expression, this is actually our answer. This thing here is equivalent to the square root of 9 minus x squared all over 3. It's a nice exercise in algebra.